Hey everyone, this is Lalit here again. In this particular video, we'll start with fabled Python package named Pandas, which has become de facto tool for handling datasets in Python. In this video, we will look at following aspects of Pandas: manually creating data frames, reading data from external files, peripheral summary of the data, subsetting on the basis of row number, column numbers, subsetting on the basis of condition, subsetting on the basis of column names. Let's import the package first and then we'll create data frames manually. There are two ways to create data frames. From list of values as columns, let's first create some list values. We can zip these to convert them to a single list of tuples. Each tuple in that list will correspond to a row in the data frame. So zip function does this. Each tuple here comes from zipping the corresponding values from these lists that we created earlier. When you run these codes at your end, you will have different values because we are creating them randomly. So don't worry about if these rows are not matching. Okay, we can put this into a data frame simply using the function pd.dataframe. Okay, so this is a simple data frame, 3 columns and 20 rows with these lists as columns. We could have given some different column names also. It doesn't have to necessarily match with the list object name that you created earlier. Another way is to put these in a dictionary. You will not need to supply column names separately in this case. They will be picked as the values of the key themselves. So this is here I'm passing a dictionary with key names or key values being taken as the column names, and this is the list which contains the values themselves. The result is same. Just the process of creating them is different. There is no difference in properties of end result. We can read data from external file very easily using function read_csv from Pandas. Let's create a string containing file name first. Here notice that R is added at the beginning of the path. This is to make file a raw string so that it's treated as path as is, and any special occurrence is not interpreted as the special meaning by Python. For example, \n means new line, which will be ignored when we add R at the beginning of the string. ld.head. So it by default prints 5 observations. If you want to print a varying number, this will print 10 observation. To get column names, we can look attribute column of the data. So it contains all these columns. To see type of these columns, we can use attribute dtypes. Float 64 here corresponds to numeric values. An object corresponds to categorical columns. To know how many rows and columns are there in the data, we can use attribute shape. This tells us that the data has 2500 rows or observation and 15 columns in it. Now let's subset this data on the basis of row and column numbers. Keep in mind that count starts with 0 for both. iloc here corresponds to subsetting by position. To understand this better, let's try to further subset this data. Right now we have 4 rows and 4 columns. This index here is coming from the original data. In the original data, it started with 0 and went on until 2499. We have picked some row from in between, and these corresponded to the 4th, 5th, 6th and 7th row, with index 3, 4, 5, 6 in the original data. Let's subset this further. LD1. As you can see here, the position is relative to the current data, not the original one. Okay, so you end up getting third and fourth rows of the new data. So it's relative to the current one. Doesn't look for these rows from the original data. Generally, however, we do not subset data by positions. We subset by either conditions or column names. If we are subsetting just on the basis of conditions or just column names, we can directly pass those in square brackets. This here will give me those observations which correspond to these conditions taken together. So LD home ownership equal to mortgage and LD monthly income greater than 5,000. Notice that when you are combining multiple conditions, you will have to enclose them in the parentheses. Otherwise, you will either get an error or weird results. Look at the results. Home ownership is mortgage as is specified, and monthly income greater than 5,000. All the cases. These two conditions will hold together for all these observations. If you wanted to extract a single column, you can simply pass the name in a single square bracket. So that gives you a single column. However, multiple columns name need to be passed as a list. So if I wanted to extract both home ownership and monthly income, I will have to pass them in a list. See here, double square bracket, do notice. So these column names need to be passed as a list. When using both condition for the rows and column names for selecting the columns, we need to use .loc with data frame name, like this. So here .loc, ld.loc, within the square brackets for subsetting. On the row side, we have put in the condition. On the column side, we have put in list of columns that we want to extract. So the resulting data now will have only two columns which correspond to these conditions, as you can see. In order to negate a condition or drop rows on the basis of a condition, we just need to add a tilde symbol in front of the condition. The same code here. Let's first enclose this entire thing into small brackets and put a tilde in front here. So that essentially negates this. It will get all the observation where this doesn't hold. So this condition was both home ownership should be equal to mortgage as well as monthly income should be greater than 5,000. So anywhere where either of these conditions are not true, it will give you that observation. So here, although home ownership is mortgage, but monthly income is less than 5,000. Here both of the conditions do not hold. Here monthly income is greater than 4,000, but home ownership is mortgage. Okay, so it gives you rest of the observations or negates the condition. Next is we want to drop columns on the basis of names. We can make use of the inbuilt drop function. This here ld.drop and give the list of columns to drop along the x is equal to 1 because these are columns. This will give you an output which contains all the columns except home ownership and monthly income. See here, it doesn't contain those particular columns. However, if you look at the columns in here, you will see that home ownership and monthly income are still there. What happens is that ld.drop function by default gives you an output. It is not making in-place changes. So in order to drop them, you can do two things. One, you can equate the output to the original object. So if you write ld equal to ld dot drop, now the data doesn't contain these columns because we equated the output to the original object. You can make use of the in place option in the drop function to change the data in place. You will not have to equate the output to the original object. So here if I write ld dot drop, debt to income ratio state x is equal to 1, in place equal to true. This will not give you an output, and if you look at ld dot columns, you'll find that further debt to income ratio and state also have been dropped. One more thing that you need to be careful with here is that when using in place equal to true option, function drop doesn't output anything. So don't equate it to original data. If you do, original data will end up becoming a none type object, which we discussed earlier also. Another way to delete a column is to use keyword delete, the same one which we use in context of dictionary. So if I write this will remove the column employment length from the data. Let's confirm. You can see here employment length is not there. We will stop our discussion on Pandas data frame in this video. In the next video, we will see how to add new columns and modify existing columns in the data. We will also see how to check, count and impute missing values in the data in the next video.